Hey everybody, Jake here coming at you with another live math lesson this Monday night, 5 o'clock Pacific time, 8 o'clock Eastern. Today is Monday, February 6, 2013. Today we're going to be going through some examples of doing synthetic division, which is basically just a way to do polynomial long division, but for a very specific type of problem. It's basically just a nice little shortcut that you can apply on some polynomial long division problems that makes it a little bit easier to go through the process. I talked about polynomial long division last week, and so this week I just wanted to kind of take it a step further and show you this shortcut because I did also mention this method in my live stream last week. So I just wanted to keep building on that. Before we jump into it, I want to quickly mention if you have any questions along the way, throw them in the live chat. I'm happy to help answer any questions you have, even if they're off topic for synthetic division, or even if they're off topic for math entirely. I'm happy to help however I can. I may not be able to answer every question you throw at me live without being able to research or prepare an answer or something like that, but feel free to throw it in the live chat. I'll do what I can. Maybe I'll come back and make a video about whatever topic you have later on. But let's go ahead and jump into synthetic division. So here's the first problem we're going to be going over. We're going to use synthetic division to divide 5x cubed plus 18x squared plus 7x minus 6, all divided by x plus 3. So these synthetic division problems so let me first point out, synthetic division method as a whole, it can only be used whenever you're dividing by x plus or minus some number. So it does have to have that very specific form. It can't even have a coefficient in front of the x. It just has to be x plus or minus a number. So all the examples we're going to be going through today fall into that category. And then the other thing you want to kind of keep in mind is basically this polynomial that you're dividing by that x plus or minus a number can basically be any polynomial, any degree polynomial. The process and the steps you're going to go through are going to be the same, whether you have an x to the 100th power here or just an x cubed power here. The only thing that you need to make sure is that you just have x plus or minus some number here. So basically, to set this up, what you want to keep in mind is basically the kind of formula that this is based on is if you have some polynomial divided by x minus k. So that's something to just be careful of. It is x minus k, whereas here we have x plus 3. So what that means is the actual k value here, x plus 3, is actually the same as x minus negative 3. So the k value that we're going to use here is actually negative 3, even though we have x plus 3 right here. So just kind of keep that in mind. That is obviously something that is a little bit weird. It looks opposite of how you might expect it to look, but just be careful about that when you're setting up the problem. So now that we've kind of pointed that out, let's go ahead and get into how to actually set up one of these synthetic division problems. Basically, what you're going to want to do is you're going to basically just set up this little division symbol thing. You're going to make sure that you have your polynomial written from the highest power x term down to the lowest power x term. So here we already have it written, x cubed, x squared, x, and then our constant term. So it's already in descending power of x, which is exactly what we want. Once you've confirmed that it's in that order, you can basically just take the coefficients of each of those terms and write them in this little kind of L-shaped division curve thing. So we're just going to take 5, write it here, 18, write it here, 7, write it here, and then negative 6, write it here. So be careful, make sure the sign does line up with the numbers you write here. And then what we're going to do is we're just going to write our k over here. So we're just going to write negative 3 over here. So this is always going to start out the same way. You're basically just going to start by taking whatever this first number is here, in this case 5, and carry it all the way down to the bottom here. Okay. Then from there, you're going to go diagonal. So you're going to go from 5 to over here, and you're going to write a new number right here. That new number is just going to be whatever this number down here was times your k. So 5 times negative 3 gives us negative 15. So we're going to write that right here. Then once you've done that, you kind of just go down this column now. So now you're just going to add these two numbers. So 18 minus 15 or 18 plus negative 15 is just positive 3. So you're going to write that there. And then you just kind of keep doing the same exact pattern. You're just going to start by carrying your first term down, and then you're going to go diagonal and then down and diagonal and down and diagonal and down until you get to the end. Each diagonal move is going to be a multiplication of whatever this number is times whatever your k value is over here. And each down move is just going to be addition for whatever the two numbers are that are in this column here, and then write the result down here. So next move now is going to be diagonal. So we're going to go 3 times negative 3 gives us negative 9. And then down 7 plus negative 9, which is the same as 7 minus 9, which gives us negative 2. And then negative 2 times negative 3 gives us positive 6. And then negative 6 plus 6 gives us 0. So now we need to kind of figure out what this actually means. Obviously, we've kind of got these four numbers here, but what does that actually tell us about the solution to this division? Because, you know, dividing this polynomial by this polynomial shouldn't get us to like a 4-digit number or anything like that. Like, we need to think about how this actually translates into a polynomial that makes sense as a solution to this long division. Before we jump into that, though, if you do have, if you are getting value out of this video, do me a favor, hit that like button down below, just smash that thumbs up button down there. Helps kind of spread this video out to more people, and so we can keep growing the Jake's Math Lessons community and keep crushing it all term long in pre-calc and calculus together. So just hit that like button and we'll carry on here. I'll show you how to kind of finish up this problem. So once you've gotten these numbers all written down here, once you've gotten all the way to your last term and you're done, this is going to kind of translate to a polynomial. So the last number that you have written over here, in this case it's 0, is always going to be your remainder. So since we have a remainder of 0, that's kind of nice. That basically tells us that this polynomial divided by this linear term actually results in a nice even polynomial. We don't have a remainder, so that's kind of nice. Then what you basically have to do is these other remaining numbers are just going to be coefficients of x raised up to some power term. But how do you know where to start? There's kind of two ways you could think about it. You could either start from the left and go right, where you know that your first x term is always going to be one less than whatever your highest x term was in the polynomial you started with. So in this case, we know that our highest power x is going to be x squared, and the coefficient of that term is going to be positive 5. And then we're just going to decrease our coefficient, or our power of x, until we kind of use up all these coefficients. So the next one is going to be 3 times x, and then the last one is just going to be minus 2 with no x with it. The other way to think about it is we could start from right to left, knowing that our farthest right term is just going to be a constant being added or subtracted at the end. And then we're basically just going to add a power of x each time as we go over to the next coefficient. So either way, you should end up at the same thing. And then, like I said, this last one is your remainder. Since we have a remainder of 0, that doesn't really provide anything here. So we can kind of just leave that out. And so we know that this polynomial right here is the result of dividing this polynomial by x plus 3. So I'm not seeing any questions in the live chat, so we'll just kind of carry on here. Like I said, though, if you do have any questions along the way, throw them in the live chat. Happy to help answer some questions that you might have. But let's keep it rolling here. And I don't know if you have seen, but I've been making some kind of new content. Not exactly just doing calculus or pre-calculus problems, but actually talking about some applications to real world stuff. Specifically, I've been talking a lot about daily fantasy sports. So if sports or fantasy sports is something that you're interested in and thinking about ways to actually apply pre-calc, calculus, statistics, things that we actually talk about on this channel and doing these practice problems out of textbooks, there are ways to apply these things to real life in sports. And that personally for me is something that I find really interesting. So I've been making some videos about that. If that sounds interesting to you too, be sure to hit that subscribe button and that bell icon down below, so you're notified when I come out with all these videos and you can come back and check it out. Goal is right now we're trying to build like a daily fantasy sports optimizer using different calculus concepts and statistics analysis. So hit that subscribe button and come along for the ride. I'm sure you'll find it interesting. So let's go ahead and jump into this next problem here. Again, we're going to use synthetic division to divide. This time we have 9x cubed minus 16x minus 18x squared plus 32 all over x minus 2. Now, just kind of talking about the form this is written in, this is the same as saying basically 9x cubed minus 16x minus 18x squared plus 32 divided by x minus 2 in parentheses. Like writing it this way versus writing it in a fraction, it's saying the exact same thing. We're basically just going to go through the same synthetic division process. So, like I pointed out, though, you do want to be very careful. We need these terms to be written in descending power of x order. They currently are not. Notice we go from an x cubed term to an x term and then back to x squared. So they do need to be in the right order. So what we want to do is think about this instead of negative 16x minus 18x squared. Think of it as negative 18x squared minus 16x. So if it helps you to actually make that change and rewrite it, definitely I would say go ahead and do that. But just something to kind of be careful of. So we'll change this to negative 18x squared minus 16x. Okay, so now we've rewritten our polynomial in the correct order that we need the terms to be in order to super easily apply this synthetic division concept. So just like we did previously, we want to first think about what our k is. Now, remember, the thing we're dividing by, you should always think of as x minus k. So if this is a negative here, your k is going to be positive. If this is x plus some number, your k is going to be negative. So since we have x minus 2, that tells us k is actually positive 2, not negative 2. So just be careful of that distinction there. Once you've done that, we can actually start by writing our kind of bracket down here. And then since we already got our x terms in the right order, we can just write their coefficients. So 9, negative 18x squared, negative 16x plus, don't need to write the plus, sorry, plus 32. And then again, we'll start by writing our k over here. So our k is 2. So again, we always start by just dragging this first number down to the bottom here. That's going to kind of carry through into our polynomial that we get as a solution. Then you're going to go diagonal. So now we need to write a number here. That's just going to be the product of these two numbers multiplied by each other. So 2 times 9 gives us positive 18. So then negative 18 plus 18 gives us 0. Okay. Then diagonal, we're going to take the product of this number here, 0 times positive 2 gives us 0. Then we're going to add these two numbers in this column here. So negative 16 plus 0 gives us negative 16. And then we're going to move diagonal and do a product. So negative 16 times positive 2 gives us negative 32. And then we're going to move down and write a sum. So whenever you move down, you're writing a sum of the numbers above it. Whenever you move diagonal, you're writing a product based on the number that you have down below and over here to the left. So 32 minus 32 is 0. So once we've written these four terms here, now we can actually figure out how this translates to a polynomial. Again, you're always going to start, you can start left to right by starting at whatever your highest power x term was that you had in your numerator of your fraction. You'll take one less than that. So we're going to start with an x squared term in our solution because we started with an x cubed term in the beginning of our problem. So we have this coefficient, 9, and then x squared, 0x, because we're just going to lower our power by 1. 2 minus 1 is 1. X to the 1 is just x. Then after a straight up x term, we're just going to have a coefficient, or not a coefficient, I'm sorry, just a constant number being added or subtracted, so minus 16. And then this last number here is our remainder. Remainder of 0 doesn't really mean anything. So just having this polynomial here is our solution to this fraction. However, we do want to be careful because whenever you have a 0, like 0x, go ahead and simplify that out. 9x squared plus 0x is just plus 0, which doesn't do anything, and then minus 16. So now this is the polynomial that we get by using synthetic division to divide this polynomial and this linear term that we started with. Not seeing any questions in the live chat, so we'll keep it rolling here. Got another problem to go through with you guys here, so let's scroll on over to that. And we'll, again, jump right into using use synthetic division to divide negative 3x to the fourth all over x plus 2. So again, whatever's on your denominator, you need to make sure that it's just x plus or minus some number. If so, you can use synthetic division, assuming you have a polynomial on your numerator. That obviously has to be the case also, because synthetic division is a form of polynomial long division. So you definitely need a polynomial, and then you need a linear term that just has an x coefficient of 1. So it's just going to be x plus or minus some number. Keep in mind, we need it to be x minus k. So the sign is going to be opposite. So x plus 2 tells us our k is actually negative 2, because x minus negative 2 is x plus 2. So then what we're going to do is confirm if our numerator is already in the right order, where we have our highest powered x term first, going down to our lowest powered x term, and then our constant number being added or subtracted at the very end. In this case, we only have one x term. So how do we deal with that? Well, what you can do is think of negative 3x to the fourth is basically the same as negative or plus 0x cubed plus 0x squared plus 0x plus 0. So if you ever are, missing any powers of x in the middle of your polynomial or towards the end of your polynomial, you kind of need to fill in the gaps with zeros. So make sure that when you write your kind of synthetic division bracket here, make sure that whatever your highest power x is going to the farthest left. And then make sure you have enough zeros or enough terms in general to get you down to your constant number being added or subtracted at the end. So in this case, that's a bunch of zeros, but you do need to have those because they hold the correct place so that we can actually figure out what those other terms would be. So doing this, we would have a 0, a 0, a 0, a 0. So we need 4 extra zeros to get from x to the fourth down to our constant number all by itself. If it helps you to write all this out like this, I would definitely recommend doing that. But kind of a shortcut there too even is whatever your highest power x term is, so in this case x to the fourth, you need one more total term than that. So we have 5 total terms here based on the fact that we have our highest power x as x to the fourth. Okay, so once we've done that, we can write our k over here. So k is negative 2. That's not the best looking 2. There we go. So a little better. And then we can start by going through the synthetic division process. So we're going to always start by just carrying, whoops. Uh-oh. Okay, sorry about that. So we're always going to just start by carrying our first term down. So negative 3 is going to be written right here. Okay, then we go diagonal. Diagonal is always going to be multiplication. So we're going to go negative 3 times negative 2. Gives us positive 6. And then we're going to go down. Going down is always addition. So 0 plus 6 is 6. So this is, again, you're just going through the same steps. You're basically just zigzagging down, diagonal, down, diagonal, down, diagonal, down, diagonal, until you get to the very end and have the same number of terms down here that you had up here. That's really all you're doing. Whenever you go down, you're adding. Whenever you go diagonal, you're multiplying. So now we have a 6 times a negative 2 to do our next diagonal move. Gives us negative 12. Now we're going down. So we add 0 plus negative 12 is negative 12. Now we're going diagonal. So we multiply. Negative 12 times negative 2 gives us positive 24. And now we're going down. Whenever you go down, you add. So 0 plus 24 gives us 24. And now we go diagonal. Diagonal is multiply. So 24 times negative 2 gives us negative 48. And now we go down, so we add. So we go 0 plus negative 48 gives us negative 48. Okay, and now we have 5 terms down here at the bottom. We had 5 terms up here to start. So now we know We're done doing the down diagonal thing. We've gotten to the end of that. But now what we need to do is think about how to translate this into a polynomial. So to do that, there's really just one thing you need to think about. But if you are getting value out of this video so far, do me a favor, smash that like button down below, hit that subscribe button and that bell icon too while you're down there so you can be notified when I come out with all my new videos. We can keep crushing it all term long in calculus, pre-calculus, you know, whatever math you're taking. We'll keep going through problems like this together throughout the term. So hit that subscribe button. Now to finish this off, we'll kind of wrap it all together here. Start with whatever your highest power x term was at the beginning, so x to the fourth, and then take 1 away from that. So we're going to have an x to the third to start down here. Now you're just going to put this as your coefficient, your first term down here as your coefficient of this highest power x term down here. Then you're going to do this coefficient times the next power x term down, so x squared plus 6x squared. Then this number times the next x power down, so minus 12x. And then this second to last number is always going to be your constant coefficient term. I keep calling it a constant coefficient term, just your constant term. Sorry about that. So 24 plus 24. And then this final number here is always going to be your remainder. So basically we have a remainder of negative 48. But that's not really the best way to write this. What we probably want to do instead is write it as minus minus 48 over whatever this was, the denominator of your fraction originally. So minus over x plus 2. Another way we could write this, just to, you know, if it helps make it a little bit easier for you to follow, negative 48 is our remainder. So we'll just put negative 48 as our numerator and then just say plus. So now this is the result of dividing negative 3x to the fourth by x plus 2. You end up with all this. So that's all I had prepared for you guys. If you did get some value out of this video, do me a huge favor, hit that like button, thumbs up button, hit that subscribe button and that bell icon too, so you'll be notified when all my new videos come out. And we'll keep crushing it all term long in calculus. Like I said, I've been talking about some applications of calculus and statistics in the real world, specifically around sports and fantasy sports. I'm having a lot of fun making those videos, and I think you'll have a lot of fun watching them. So be sure to hit that subscribe button, keep checking back for all my latest videos, and I'll see you back next week for the Monday night live stream at 5 o'clock Pacific time. See you then.